And we are recording now. Welcome to discussion section 10 for the graphical and numerical summaries with R. Okay. Okay. So the objectives for today are that we are using R to generate random numbers from continuous distributions. And we are going to look at the visualizations for those samples that we generated. And then we're also going to look at some summary statistics like sample mean, sample variance, median, and the median of absolute deviation, which is also abbreviated as MAD. Okay. All right. So first thing first, histograms. We have talked a little bit about histograms before, like you guys have gone over this in lecture 31. And then we are gonna basically use this in R, and the main R function that plots the histogram is called hist, H-I-S-T, and it takes some arguments like X and breaks. Okay, X is just your data, and you can also specify breaks, like where do you want to break your data in X-axis and so on. Like how many number of breaks you want or stuff like that. You can do that using the argument breaks, and you can also give it a vector that would tell where to break. Okay, what do I mean? So for example, here we're generating a vector X of values 0, 100, 200, so on to 800. And this is a vector for the breaks. Okay. If you want to know more about histogram and its arguments, you can also type question mark HIST in R to learn more, or you can go to the help page and type hist. Okay. But look, let's say here my data is called the air passengers data. And my breaks that I specify are the one from the vector I created right here. And I said, these are the breaks. Now let's see how that works. You see this histogram that has some data that I will get from the air passengers. And where is it breaking up? It's breaking up as I told it to 0 to 100 to 200 and so on. You see there is a bin at every 100 level. Okay. All right. Now you can also plot this histogram using the ggplot2 package. We use the function called gmhistogram in ggplot2, and then what are the arguments that it can take? We can specify the width of the bins, just as you saw these bins in the histogram. These bars are called the bins. We can say how wide or how how wide do we want these bars to be. So that's called the bin width. You can specify that, and then you can specify the number of bins you want by the argument called bins, or you can also supply a numeric vector as we did before. Again, there's another argument called breaks in the GM histogram that you can supply stuff like that. But if you use breaks and you also use bin width, then breaks argument will override the bin width argument. So if you use breaks, it will and bin width, then bin width will be ignored, and it will use the breaks argument. Okay, and now we can also add and align to the histogram. Specifically here, what we're going to talk about is a vertical line. Okay, so this vertical line, like for example, I want to know, I have a histogram plotted and I want to know where's the mean. I want to plot a vertical line for its mean. So I can specify GMV line at the mean of the data, and it would do that. So for example, here, you can see these bins, right? And then we specified this vertical line at mean right here. So forget about the data above. I'll talk about that in a minute. Look at this ggplot, okay? So as we know, ggplot takes the data frame. So we had some data and we converted it to data frame. And then the aesthetics it's taking is x equals to air passengers. So that's the column names. And then we are plotting a GM histogram, okay? And then breaks, as we discussed before, this is the vector of breaks that we give it. And then we can choose the color as black. This is the color of the histogram. As you can see, the black outline. and fill white. So here we just chose it to fill as our white. You can choose whatever you want to. And now look at this GM line. So GMV line gives me a vertical line, and it takes x-intercept as the mean of air passengers. So we are specifying where we want this vertical line. We want at x, where x is the mean of the air passengers. That's where we want this line to be. And then we can specify the color of the line and line type so that we can change those, of course. Okay, any questions so far about the ggplot stuff? Okay, I think I can move forward. For this data frame, this is just, so when we are using ggplot, we typically give it a data frame and not just the random data. So let's say we have this data air passengers, we are just converted it to data frame. You can just do data.frame and convert that. And here we are just trying to create some nice variables called year and month using a variable called truncation on the variable time. So let's say we have a time in this data air passengers, and this year is just truncating the year from the time variable. So time variable has time and year, so we are just truncating the year part. And for month, this is just abbreviating the cycle it has. The variable cycle probably has the name of the month, and this is just abbreviating. So for January, it will have JAN and stuff like that. So it's just trying to make this data frame look nice. Okay, now let's talk about kernel density estimate. As shown in lecture 31, we introduced generic density function, right? So this is our function called density, which takes the data and it takes the bandwidth, BW, and it takes a type of kernel you want. So for example, Gaussian or triangular, whatever you want to. And it gives you the density. Now, remember, this gives you the density. And if you want to plot this density, then you say plot, just in general R. You plot with all these commands of density, and it will plot that. Okay. Now, if you want to know more about GM density, again, you can go to the help section in R. Okay. So now again, we can also plot the density using the ggplot package. Sorry, I should correct myself, ggplot2 package, right? So we can specify the smoothness of the bandwidth via the argument BW, and then again using kernel, we can specify what kind of kernel we want, and then we can know more about it also using the help package in R. So this is the little code that generates a similar kind of function as we did before, but now using ggplot function rather than just normal R plot function. Okay. Okay, any questions so far? Yeah. All right, so there are some summary statistics that we have discussed in lecture, like the sample mean, sample variance, sample median, median of absolute deviations, and so on, right? So these, we have these formulas, particular formulas to calculate these statistics. Now you can also calculate these statistics using R, using the functions in R. Okay, so already inbuilt functions in R. Like for mean, we just use a function called MEAN and give your data in it, so it will automatically use this formula to calculate the mean of that data. So you don't have to specifically add everything up. Okay. All right. So box and whisker plots. So in lecture 32, you learned about the box and whisker plots that give you the information about the mean of the data, median of the data, outliers of the data, right? So those kind of, you have a box and with the lines, so it's called the box and the whisker plot. You can use the function box plot to just as a normal R function to plot a box plot, or in the ggplot2 package, you can use GM box plot. And again, if you need the help about this, or you want to know more about this function, and then you have the help option in R. All right, to worksheet 10. Please follow the instructions given in the worksheet. You do have a template for the given to you on CAT courses. So please follow that. All the instructions are given there. Please submit an HTML with all these instructions, otherwise you will lose some points. Okay. Any questions? Then I'm going to stop recording now.